Hello and welcome to this video on complementary counting, a topic discussed in the AoPS summer class which I just completed. I really enjoyed learning about this topic, so I decided to make a video about it, basically outlining what problems to use it and how to use this method to solve counting probability questions. So the complementary counting method is used in many advanced counting and probability books and textbooks and questions from many different math competitions. So basically what you do with complementary counting is you find out the complement, basically what fills a whole event to one event. So basically if you have one event, the complement is going to be the opposite of this event, or what makes an entire probability. So like in this problem over here, two standard six-sided dice are rolled. What is the probability that at least one of the dice shows a number less than 3? So the complement, this is the first step you want to take whenever you are dealing with a problem that requires complementary counting. You first want to find the complement to an event. So the event in this case is one of the dice shows a number less than 3. And the complement to any event that's like less than or at least is going to be the opposite. So less than 3, the opposite is greater than or equal to 3. So that's the complement in this case. The complement, let's write this down. The complement is that one of the dice is greater than or equal to 3. That's our complement for this event here. So, now that we've found the complement, we then want to figure out the total number of outcomes. That's an important step in any counting problem. Because when you're finding probability, the probability is the number of successful outcomes over the number of total outcomes. So it makes sense that you'd want to find the number of total outcomes to start. So there are 4 total results for this complement. 3, 4, 5, and 6. Results are 3, 4, 5, and 6, okay? And all 3 results that are greater than or equal to 3. And these 4 events are going to be out of the 6 results in total, because they said this is a 6-sided die. So that's 4 results out of 6 over here. 4 over 6. 4 over 6 equals 2/3. Now this is not the final answer. We're just finding the probability of the complement. What we want is to find the probability of the main event, which in this case is the dice showing a number less than 3. So to find the main event, we first basically note that is these 2 events, are they independent or dependent of each other? So an independent event is when you can change one and not have the have the complement change as well. But then with a dependent event, both the complement and the main event change. So in this case, the 2 rolls, the 2 dice, are rolled independently. They're not as one die. So that means that these 2 rolls are independent of each other. So what we want to do here is we want to multiply the probabilities of each die. This is just for one die here, one of the 6-sided die. And then since they want the probability for 2 of the standard 6-sided dice, we do 2/3 times 2/3 to get 4/9. But that's still not the final answer, because in any complementary counting problem, to find the main event, once you find the probability of both the dice in this case, you have to subtract the final probability from 1, because remember, this is the complement. And since the complement is only part of a whole, we must subtract it by 1 to get the final probability. So we do 1 minus 4/9 to get a final probability of 5/9. And that is the final answer for this question. This is this is a very typical counting probability question that you find in many books, like this one over here, AoPS book. And it came up quite often in that AoPS summer math camp I recently took. So this is a very useful method for solving counting and probability questions that require multiple events, and usually problems that say dice or whatever showing a number less than 3 or whatever. Could be at least or less than. That's usually your cue that you're going to want to use complementary counting for the problem.